December 10th, the remainder and factor theorems. We will discuss dividing polynomials using long division and synthetic division, and we will use those division strategies to factor a polynomial and find zeros or the x-intercepts of a polynomial function to help us better sketch later on. We will set this up as if we were dividing a 3-digit polynomial by a 1-digit polynomial, or a 5-digit number by a 3-digit number. Let's see how this worked with numbers first. If I had 407 divided by 6, I would take 6 times what goes into 40 first, multiply 6 times 6, and then subtract. So notice what times 6 goes into 40, multiply, then subtract. What times 6 goes into 47, multiply, and we'd subtract. And we'd say this is 67 and 5/6. That'll be helpful later on about that remainder. So let's see notice whenever I wrote out the polynomial that I had a placeholder for x squared. Since it wasn't written in the original problem, you need the 0x squared. So what times, now I'm going to be looking over in the divisor. I need to ask what times x squared could get me to 2x to the 4th. I will then take 2x squared times the divisor and write it beneath the 3 terms in the dividend. But I need to remember from before, after I multiply, I then subtracted. So I will subtract this entire polynomial. And I'll bring down the next term. I ask myself what times x squared will get me to 7x cubed. 7x. So then I multiply through that 7x with the divisor, x squared minus 2x plus 2. I write it beneath, and I remember to subtract that product. And I bring down the next term. What multiplies to x squared, that'll give me a 10x squared. And I write it down. Multiply 10 throughout the divisor and write it below. Subtract the product. Notice what's left. This 11x minus 21, I can't take x squared times something to get 11x. So this is my remainder. Watch how I write the remainder. I will put plus 11x minus 21 all over the divisor, which is x squared minus 2x plus 2. Notice how whenever when we divided over here, we wrote the remainder as 5/6, 5 being the remainder over 6 the divisor. That's how we will do with the polynomials. So our final answer, 2x squared plus 7x plus 10 plus 11x minus 21 divided by x squared minus 2x plus 2. Try this next example. Be sure to hold a 0 in the place of the y cubed term. Try this on your own and then look up at the screen to see if you got it correct. Pause the recording now. ending answer, y squared plus y plus 2 plus 3 over the quantity y squared minus y plus 1. Synthetic division will be a lot like synthetic substitution. We will have a box with a line, and we will write the coefficients of the dividend in standard form. Notice how our exponents go x cubed, x squared, x, and then x to the 0 power. But we got to figure out what goes in that box. If I take the divisor, I need to figure out the 0. The 0 would be what makes the divisor be 0. If I solved this, x would be 2. This is the number that will go into that box. Now we're going to do this like synthetic substitution. Drop down the first coefficient, multiply 1 times the boxed number, and then add. Multiply, add. Multiply, add. Typically, whenever I plugged in, if I were to plug in 2 into that polynomial, we would say 5 is our answer. But with synthetic division, I now need to realize that this is actually some kind of polynomial. I started with an x cubed term. If you divide an x cubed term by a linear term, I drop down by 1 exponent. So when I drop my first coefficient, this now becomes x squared. These are our new coefficients of a quadratic. So my answer would be 1x squared plus 4x plus 2 plus 5 over the divisor, x minus 2. Let's try it again. Pause and then check at the end. Instead of writing our solution as x squared minus x minus 3 plus 0 over x plus 3, we just write it as x squared minus x minus 3. When you get a 0 in this spot, that means there's no remainder. So the factor, or x plus 3, is technically a perfect factor of x cubed plus 2x squared minus 6x minus 9. In other words, x plus 3 times x squared minus x minus 3, if we needed a factor, this is what it would look like from that big polynomial in the beginning. In this problem, this is telling me that if you plug in -3 using synthetic substitution, I'm going to get 0 as a remainder. So if I use synthetic division, I could figure out the other polynomial expression that'll help factor that. (2x squared plus 5x plus 3 is a factor, and using, if -3 is a 0, then that means x plus 3 is a factor. I can still split up that quotient of 2x squared plus 5x plus 3 using any quadratic strategy to factor. This breaks down to 2x plus 3, x plus 1, and x plus 3. When examples say find the other zeros of a function, you're finding numbers that'll give you a 0 as a remainder, or an x-intercept also. If we know 2 is a 0, we can use synthetic division to figure out possibly the other zeros. The resulting quotient would be x squared minus 9 since the linear term is out. If I want to find the zeros, I want to see what will make this 0. If you solve it, it turns out to be x could also be positive or negative 3. Since we started out with a cubic function, notice how 2 is a 0 and positive and negative 3 are also zeros. We actually come out with a total of 3 zeros. 2, positive 3, negative 3. But the other zeros are plus or minus 3. Pause this screen or pause the video to look at these direction words. To factor, we will undistribute. Notice what our answers will look like. To find zeros, we're going to find a value for the variable, which will make the polynomial expression equal to 0. Notice what these answers look like.